All right, we're back. We are on page 3 of notes 3 of Calc C, which it always just sounds like I'm rhyming or something when I say those. And we're talking about sequences. Ooh, I'm getting some messages there. So what we want to do in this particular problem is we want to make our calculator generate 8 terms of the sequence, find the value to which the sequence converges, if it converges. So some calculator stuff. So that's good. So let's see. Let's switch over to the calculator and see what we can do. So here we go. All right, so how do we make a sequence on the calculator? I'm gonna start a new problem, doc for enter, and calculator page. So you can see I'm on problem number 2, and problem number 1 is over here in case I need to go back to it, which I definitely don't, but I like to show you that you can do those things just in case you want to. All right, so how do I make a sequence? I think the easiest thing to do is type SEQ, and then do parentheses. It's in, I can never remember where it is because I exclusively do that. I assume it's in statistics and like list operations probably. Sequence, yep. So what was that? 645, 645. I don't know if that's easy to remember. Sequence, so what you do is you type in the function. We got this, so this generates the terms of our sequence. You gotta tell it the variable, so that's n in this case. Then you got to tell it where you want to start and where you want to stop. So it's not obvious where to start this. So I'm going to start it at 1. I don't know. And then I need to get 8 terms. So I'm going to end at 8 because that'll give me 8 terms. So if you had started at n equals 0, which you could because there's nothing about this problem that says you can't, you would have stopped at 7 because there are 8 terms there. You got the way you figure that out is like where you end minus where you start plus 1. So 7 minus 0 is 7, plus 1 is 8. Also, you can count it on your fingers if you want to. Totally up to you. What happens is we do get a different sequence. Usually isn't totally relevant to the problems that we're doing. So I decided to start at n equals 1 because it didn't tell me otherwise. So I'm going to say that this, I'm going to write this by hand. I'll actually, let me switch over and show you what I'm doing. So I'm saying equals, and then, whoa, hold on, I scrolled instead of doing the thing I was supposed to do. So I'm gonna say this problem equals, and then, what did I start with? So it went 2, 4, 2, 4, 2, 4, 2, 4, and then I'm gonna do comma, dot, 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 because it goes forever, right? So now the question is, does this converge? Well, is it approaching a number, right? So you go out to infinity. Would you expect to get a particular number, or would you be like, well, it depends. Maybe I'm getting 2, maybe I'm getting 4. So I'm going to say, since the limit as n approaches infinity of 3 plus -1 to the n does not exist, the sum, not the sum, sorry, the sequence diverges. And that's my answer, right? So there's a lot going on there, though. I mean, we like use the calculator to generate the sequence, the terms of the sequence. That's good. Then we looked at the limit of the sequence. It doesn't exist, which means that the sequence itself must diverge. So, you know, as with almost everything that we do, there's a lot of like little background things that go into virtually every problem. And what am I even doing? So, okay, I'm back at the calculator. I don't know. I thought I got confused. All right, let's do the next one. Sequence. N over 1 minus 2n. So here, is there a problem? If n is, no, because if n is equal to, so this is one of those weird things that happens, right? So if n is equal to 1/2, then this generating function here has a big problem, right? Because you can't plug in 1/2 because you're dividing by 0. But n can't be 1/2. So we're not in trouble. I'm just going to go from 1 to 8 again, and I'm going to write down my terms. So, all right, so it's negative. So -1, -2/3, -3/5. So it's like the counting numbers, the negative counting numbers over the odds, I guess. Oh, hopefully that's right, because that's what I'm going for. -5/9, yeah. -6/11, -7/13, -8/15, comma, dot, dot, dot. Okay, so now the question is, what's the limit of this thing? So you can look at it and just work out the limit. Another option is to ask the calculator for the limit. So let's do the limit as n goes to infinity. You should use use the pi key a couple times to get to infinity, like there. And then I'm going to type in n over 1 minus 2n, negative 1/2. So I'm going to go back to the notes and write that in. So this is what we want to be doing, right? You go from the when appropriate, grab your calculator and just let your calculator do the work. That's the easiest thing. So I'm going to say, since the limit as n approaches infinity of the quantity n over 1 minus 2n equals negative 1/2, the sequence n over 1 minus 2n converges to negative 1/2. Converges on or converges to? I'm not really sure which one I prefer. I feel like I'm gonna run out of like vertical spacing with my explanations over there, but we'll see. All right, let's do the next one. Maybe I'll do 2 of them while I'm there. Oh, maybe not, because part D looks a little weird. Sequence of n squared over 2 to the n minus 1. So the denominator is exponential, which means it's going to grow faster than the polynomial. So like I'm fully expecting the limit to be 0. The question is like, what do the terms do? So you cannot start this at 0, because if you try to start at 0, 2 to the 0 is 1, 1 minus 1 is 0. Division by 0 never works. Also, you get 0 over 0, which is even weirder, because like you can't really take the limit because this is a discrete function. Like you're only using integers, so you got to watch out for that. So we have to start at 1, end at 8. Get exact values. Yeah, all right. So let me write those down. What do we got here? We got square. Well, obviously there are squares on top. And then obviously it's 1 less than the powers of 2 in the denominator because I just read the function. So 1, so 4/3, and like all of that, does it help me? I don't think so. Let's see, 4 squared is 16, and then what am I doing? It's 15. Yes, okay, so 5 squared, 2 to the 5th is 32, minus 1 is 31. I mean, I should just be copying them, but so then the next one though, it's like, it's really 36 over 63, but it's simplified it. It's like, I'm not a big fan of simplification. It's just like not super great when you're trying to find patterns. If somebody went through and simplified all of your ratios, like what am I supposed to do? You know, so don't oversimplify. And I know that that's like counter to what you were, what was hammered into your head in like algebra type classes, but you know, it's what you got to do. All right, so let's see. Let's go back and write our thing about converging to 0. How do we know it converges? Because the limit is equal to 0. So I have messed that up. Here we go. Every time, so I've been like just cranking out these videos, and it's killing my screen time reports that I keep getting, and I feel personally attacked by the screen time report. N squared over 2 to the n minus 1 is 0. Therefore, yeah, let's get rid of since and just say therefore. Let's move this. Trying to save a little bit of space. I don't think I'm going to fit it though. Well, we'll see. Therefore, n squared over 2 to the n minus 1 converges to 0. I don't know. It's a little better. Very little better. All right, now this is the first time maybe that we have a factorial versus, I don't even know what to call n to the n. It's like a, I don't know. Sometimes you call it a power tower. I don't know if that's like a specific, I don't know if that's a real thing or just what like math contests sometimes call them. I mean, it's probably real, but it's also not a very big tower, right? And so 0's out. Let's go 1 to 8. I'm gonna go, I don't want to write any of these. I'm going to go with decimals, I guess. 3 decimal places. So 1, 0.5, 0.222, 0.094, 0.038. This is annoying. Also, I mean, pretty clearly the limit is 0, 0.0 1, 5. What's nice is by going 1 to 8, like I know where to stop. 0.006. I mean, you could argue I probably should stop sooner since it's so clear what's happening here. All right, I'm just going to do the next one while I'm here because that's what I want to do. So that limit is definitely a 0, right? Limit n factorial over n to the n. So n to the n, I mean, if you think about it, you can work out that that's going to be 0 because like pick a value of n, like 5, right? So the numerator is 5, 4, 3, 2, 1. The denominator is 5 times 5 times 5 times 5, like it's 5 5s, a product of 5 5s. But the 5s aren't decreasing, they're just staying 5s, whereas in the numerator, you started at 5 and you're decreasing. So like eventually you end up with like 1 over infinity if you took the limit to infinity as like the last term in that product. And 1 over infinity is definitely 0. So like you're definitely getting 0 here. That's my like fake way through that problem at least. And then finally, this one we didn't talk about this one. This one you can like look at and just kind of know what's going to happen, right? So cosine of 2 pi times n, which means we're always just getting a multiple of 2 pi, which means what is the cosine of 2 pi? The cosine of 2 pi is the same as the cosine of 0, which is 1. So this is just going to generate 8 ones, and it does. And the limit is pretty clearly 1. So this is different from like the first one where we were alternating between 2 and 4, 2 and 4, and it's like, what's happening? Here it's just 1, 2, 3, 4, 5, 6, 7, 8 ones. Okay, so I'm gonna go back to the notes, show you a thing that I should have changed, and then write down a bunch of like, does it converge and why type situations. Then I'm gonna stop this video and come back in the next one and do that. So one thing that I definitely should change is that this should have a ... at the end because this goes on forever. Also, I just noticed that these have different names. Okay, I didn't screw that up yet. I was on the way to doing it though. Move you and do comma ... And then we'll say that the limit as n approaches infinity of n factorial over n to the n is definitely 0. Therefore, the sequence, in fact, so you'll notice maybe potentially, if you're watching all the videos, you'll notice I make fewer mistakes with the sequence versus series thing as this goes on because I've been saying sequence a lot more. And then here, you can also see this happened, right? So in my head, out loud, I was counting. It's like 1, 2, 3, right? 1, 2, 3, 4, 5, 6, 7. I tried to make a 7 instead of writing the 7th one. I don't know, brains, what good are they? The limit as n approaches infinity of cosine of 2 pi n equals 1. Therefore, the sequence, which is just all the terms that can get spit out of this thing, converges to 1. And we got it. All right. So this is just a look at like how to use your calculator to generate terms, how to use your calculator to evaluate limits, if the limit exists and is finite. Actually, I should have done, let me just go back really as quickly as I can. I would just want to show you what happens on the first one if I try to take the limit. So if I do the limit, maybe I did this, I don't remember. It's been, is it too long? Have I been doing it? Is this a long day? Hard to say. Just undefined, right? So it doesn't tell you 2 and 4, it doesn't average them, it just doesn't exist. All right, so back to the notes, say goodbye, see you in the next video. As soon as I get back to the notes, I just like to end on the notes. I don't know, because we're taking the notes, you know? So here we go, that's what we worked on. Be back in the next video, talk about the rest of this page, and I will see you there.